Unit 10 will be a pretty important unit to get you ready for what you'll get off and running with in Algebra 1 next year. In Unit 10, we'll be talking about the slope of a line in Part 1. In Part 2, we'll talk about slope-intercept form. And in Part 3, we'll talk about graphing from slope-intercept form. So the first thing we're going to talk about in Part 1 is how to find the slope. The slope of a line is the ratio of the line's vertical change to its horizontal change. So when we say ratio, we're talking about a fraction. So vertical change, the up and down change, to the horizontal change, which is the left and right change. So if you look, there's a definition and some examples straight out of the book. So it says, given 2 points on a non-vertical line, you can find the slope m of the line using this formula, m equals rise over run. So it's important to make note right now that m is going to stand for slope. And then when we say the vertical change over the horizontal change, we call that the rise over the run. So the change in the y coordinate over the change in the x coordinate. And then there's an example of how to find it with points, which we'll get to in a second. On the bottom of the page, it says comparing slopes. So it says you can use the diagram below to compare the slopes of different lines. Imagine that you are walking to the right. So when we talk about slope, we always act like we're going from the left to the right to tell whether it's positive, negative, or negative. So if you look at the first example where it says positive slope, it says the line rises, the slope is positive. So again, remember, we're talking from left to right. So going from the left to the right, this line rises, so we call that a positive slope. If you look at the negative slope example, going from left to right, this line falls, so we say that the slope is negative. If you look at the bottom left example, we have a horizontal line. So going from left to right, there's no change. So we say that it has zero slope. So a horizontal line has zero slope. And then our last one is undefined slope, which is when we have a vertical line. Because it's straight up and down, so the rise is just consistently up. We can't, we call it undefined because we don't know what the slope is. So horizontal is zero, vertical is undefined. So in Part 1, we'll look at 2 different ways to find the slope. The first way is from a graph. The second way will be when you're given points. So the directions say to find the slope of the line, then tell whether the slope is positive, negative, 0, or undefined. Okay? So if you look at the first example, I put 2 dots on here. Okay? I could have picked any 2 dots I want to figure out what the slope is. I picked these because they're right at the intersection of 2 lines. Okay? So to find the slope, remember we're going to act like we're walking to the right. So I'm going to go from the left to the right. I want to do the rise over the run. So that's up and down and then left and right. So I'm going to go up first in this example. So I'm going to say that I go up 1, 2, 3, 4, 5, 6 spots. So my rise is going to be 6. I then go over to the right 1, 2, 3, 4, 5. So again, I rise, I go up 6, I run, I go to the right 5, so I get 6 over 5. Then I also need to say that that is a positive slope. As I go from left to right, it's rising, it's increasing, so we call that a positive slope. If you look at example 2, I have a horizontal line. So we need to remember that anytime we have a horizontal line, my slope is going to be 0. So I say that this has 0 slope. Looking at the third example, again, I put 2 points on here for you. We're going to start from the left and go to the right. We want to do the rise over the run. So for this one, starting at my left point, I need to go down. So I'm going to go down 1, 2, 3, 4. Since I'm going down, I'm going to say that's a negative 4. I then go to the right, 1, 2. So I have 2 there. I need to simplify this, so I'll get negative 2 for my slope. And as you can see from the fact that it is negative 2, or the fact that this line falls, I have a negative slope here. So looking at 1 and 3, a couple things I want you to notice. We always go up or down first. So on number 1, we went up. On number 3, we went down. But if you notice, we always go to the right. So number 1 went up into the right. Number 3 went down into the right. So the bottom of your slope should always be positive. The top can be negative if you're looking at your graph and going left to right. Looking at number 4, we have our other special case. In this case, we have a line, a vertical line, so we call our slope undefined. So that's how to find the slope when you're given a graph. The next thing we're going to do is looking at how to find the slope when you're given 2 points. And to do this, we need to have a formula. So remember that m equals slope. We're doing the rise over the run, which is the change in y over the change in x. This triangle or delta means change. Okay, so the change in y over the change in x. So that means we're going to do y2 minus y1 over x2 minus x1. Please notice that these 1s and 2s are not exponents. They're written in what we call subscript. That's just to keep them organized, the first one and the second one. Okay, so y2 minus y1, x2 minus x1. These are not exponents, they're just for labeling purposes. So the directions say find the slope of the line through the given points, tell whether the slope is positive, negative, 0, or undefined. So I have my 2 points. The first thing you want to do is label them. So that's x1, y1, x2, y2, just so you can keep them organized. So I need to plug these into my formula. Remember, my formula is y2 minus y1 over x2 minus x1. So now I plug in. I labeled 5 as y2 minus y1, which was 3, over x2, which is 4, minus x1, which is 2. Now I can simplify that. 5 minus 3 is 2. 4 minus 2 is 2. That simplifies even further to 1. So my slope in this case is 1. That is a positive slope because it's a positive 1. Looking over at number 2. So remember that my formula is m equals y2 minus y1 over x2 minus x1. Again, m stands for slope. So now plugging in, y2 is going to be this negative 1 right here. So I have negative 1 minus y1, which is 3. Then I need to do x2, which is 6, minus x1, which is also 6. When I work this out, negative 1 minus 3 is negative 4. 6 minus 6 is 0. When you have a number over 0, your slope is undefined, which means that the graph of this would be a vertical line. So number over 0 is undefined. Coming down to example number 3, I'm going to rewrite our formula again. M equals y2 minus y1 over x2 minus x1. So now I can plug in. My y2 is 4. My y1 is 4. x2 is 5. x1 is negative 7. So 4 minus 4 is 0. 5 minus negative 7 is the same thing as 5 plus 7, so that's 12. When I have 0 over a number, that's 0 slope, which if you remember the graph would then be horizontal. So if you look at 2 and 3, you see the difference between undefined and horizontal. Or sorry, undefined and 0. Undefined is number over 0. 0 is 0 over a number. Looking at our last example now. Again, I'm going to rewrite the formula one more time. y2 minus y1 over x2 minus x1. y2 is this one right here. So that's 1 minus y1, which is 5. x2 is 4. x1 is 1. So working that out, 1 minus 5 is negative 4. 4 minus 1 is 3. And since I can't simplify that fraction, I just leave it as negative 4 over 3. And then since it's a negative number, that means I have a negative slope. Alright, that's all the new stuff for this, for Unit 10, Part 1. At the bottom are some review problems from our previous unit, finding x and y intercepts. Please make sure you get those done, because we'll come back to these later on.